our perspective on the stars is restricted. What we find in the vast fields of the universe is by no means the full picture, just a segment determined by various natural factors. But what is hidden in the part of the universe that is invisible to us? Is there even a way to unlock this mystery? Well, there is, and the data gathered suggests that there is something immense out there that has already extended its mysterious reach toward our reality. The Earth is the center of the universe, but before you think we've mentally regressed to the Middle Ages, let us briefly explain what this means. It should be clear to everyone that the geocentric view of the world, which places the Earth at the center of the universe, is long outdated. However, our blue home planet is still the center of the observable universe because, as mentioned, our view into the depths of space is limited. Given the assumption that the universe is isotropic, in other words, that it always presents itself to the observer in the same way regardless of the observer's direction, there is a spherical space around our Earth that corresponds to our cosmic field of vision. The radius of the observable universe is therefore determined by how far light has been able to travel to us since the Big Bang. According to the standard cosmological model, the universe was born around 13.8 billion years ago. You might think that this optical barrier is also 13.8 billion light-years from us, but that's not true. We mustn't forget that the universe has always been expanding, and distances traveled have been stretched as a result. Simply put, this means that the observable horizon isn't 13.8 but rather 46.3 billion light-years away. The most distant objects whose light we can observe today were only 40 million light-years from Earth when they emitted that light. Studying these distant structures is always like optically going back in time, as the light emitted from that time can no longer reach us. It's also impossible to learn anything about current events at that distance. Against this backdrop, the question of what lies beyond the observable universe seems doomed to failure from the start. However, despite all observational horizons and natural limits to vision, some experts believe they have, in fact, broken this enigma. Several years ago, researchers became aware of an unusual phenomenon that starkly contradicts our current assumptions and could lead us straight to the deepest secrets of the invisible universe. Is there a cosmic giant hiding out there? Fundamentally, according to cosmology's standard assumptions, the proper motions of galaxy clusters relative to the background radiation should be randomly distributed in all directions. And, indeed, for a brief time, the background radiation, or more precisely, the cosmic microwave background radiation, embodies a relic from a time shortly after the Big Bang, which still fills the entire universe today. Between 2001 and 2010, NASA's Wilkinson Microwave Anisotropy Probe, WMAP, was once again tasked with investigating anomalies in the cosmic background radiation. When the NASA team, led by Alexander Kashlinsky, analyzed the WMAP data in 2008, they noticed a strange pattern that shouldn't exist. The researchers observed not a random distribution of galaxy cluster movements, but rather an impressively uniform stream. And that's not all, the speed of the cosmic stream also increased with increasing distance. Most importantly, such a phenomenon must be caused by an extreme gravitational force. But what kind of structure could be responsible? Unfortunately, this question can't be answered definitively. After all, the galaxy clusters studied are moving toward a point outside the observable universe. Therefore, the cosmic flow was further investigated in 2010, and the result was that the number of galaxy clusters drifting along in the dark flow doubled from 700 to 1,400. Although there were some directional differences, all regions showed a clear correlation. Since then, cosmologists have gathered more evidence of a massive structure with an extreme gravitational pull beyond the observable universe, a tantalizing mystery. According to Alexander Kashlinsky, there's no question that matter in the visible universe cannot explain the observed cosmic motion. In this regard, the NASA cosmologist from the Goddard Space Flight Center is quoted as saying, "We lack sufficient data to see what it is or narrow it down. We can say with certainty that somewhere far away, the universe is vastly different from our local environment. Whether it's a different universe or an alternate space-time structure, we don't know." The dark flow hypothesis has been criticized. Could it be that our limited field of vision hides an immense mass of energy and matter far beyond any known scale? Or are we dealing with the effects of strange space-time curvatures resulting from the influence of an adjacent universe? Critics of the dark flow hypothesis answer these questions with a decisive neither, pointing to several potential errors by the leading researchers. A second study concluded that the dark flow is not a physical phenomenon, as the primary anisotropy, or directional dependence, of the cosmic background radiation was ignored in previous studies. Further analysis of over 550 supernovae also revealed no mysterious, synchronized movement pattern, instead showing behavior consistent with our cosmological models. Moreover, data from the ESA Planck satellite provided no evidence of an anomalous dark flow. But does this mean we can finally dismiss the hypothesis of a hidden superstructure? Not exactly. Kashlinsky emphasized that his observations are based on data from over 1,000 galaxy clusters spanning a distance of 3 billion light-years, making a statistical coincidence unlikely. The dark flow hasn't been definitively disproven yet. The question of what lies beyond the observable universe, and what it might look like, remains open. If the origin of the dark flow truly exists, this also means there must be something beyond our observable universe. Kashlinsky's team isn't alone in pondering what this ominous beyond might be. Theories on this subject are as varied as they are astounding. While one theory suggests that the invisible universe is structured similarly to the visible one, things become even more startling if we envision this scenario in an infinite space. In this case, we would eventually find all sorts of variations. In another solar system, for example, you may have had cornflakes instead of toast this morning. Some experts even believe that there is an observable universe entirely identical to our own. In other words, there is a version of you in the endless expanse of space reflecting your every action. Though this idea may seem beyond imagination, infinity also allows for infinite possibilities. On the other hand, we could just be in one of an infinite number of cosmic bubbles. According to Kashlinsky's hypothesis of an alternate universe, most of the universe may be expanding eternally, with this process only ceasing in certain bubble-like subregions. Each of these subuniverses could contain unique sets of natural constants and physical laws. String theory's multiverse concept echoes this idea, adhering to the adage, every world that can exist, does exist. We exist because there must be a world among the infinite ones where the laws of physics are perfectly suited for life. String theory further expands on this, positing that these undulating membranes in the 11th dimension encompass entirely separate universes. When the membranes collide, a new universe forms. One of the most fascinating aspects of this theory is the idea that all the gravity we experience might be leaking into our universe from another dimension. This hypothesis could explain why gravity seems so weak compared to the other fundamental forces. Thank you for watching this video. I hope you enjoyed this journey into the mysteries of the universe. If you found this video interesting, please give it a thumbs up and share it with your friends. Don't forget to subscribe to my channel for more amazing updates.